Hello everyone, welcome back to This Is Not a Science channel, and today we'll be talking about ionic bonding in our chemistry video. And ionic bonding is a major component when we talk about chemistry bonds. So it is important for us to understand and for us to discover further in detail different examples of ionic bonding. So before we actually start looking at different examples of bonding, I would recommend you to actually check back to my previous video for general advices of so the general bonding topic, and we will look into ionic bonding in this video. So from the previous video, if you have watched it, if you haven't, I'll put the link in the description. But if you have, you should be confident that when we talk about something like NaCl, sodium chloride, this is from my previous video by the way. So we have sodium and chlorine, and in order to obtain full outer shell for both elements, sodium eventually gives away one electron to chlorine and they form ions. So the product would be a sodium ion and a chloride ion. So we have Na plus and Cl minus. So there's this transfer of electron going on, and eventually we form sodium chloride as our final product. So Na plus Cl minus, and they form this kind of structure where we call it an ionic lattice. So this is what we have from the previous video, and now let's take a look at some different examples of ionic bonding. So obviously once we go deeper into ionic bonding, it's going to be more complicated. So let's take a look at several different examples of ionic bonding that is not just like NaCl where it's simple one electron transfer. So let's take a look at MgO. So MgO, we can think of magnesium and oxygen. So Mg stands for magnesium, O stands for the oxygen. So we're bonding these two together. They're ionically bonded. And I've just drawn out the element diagram just for you to visualize easily. So these are the atom diagrams. And now we are going to bond these two. And how are we going to do so? Well, let's start with making a full outer shell for both elements. So here we got magnesium, and here we got oxygen. And remember, a full outer shell is 8 electrons. So just pause the video right now. Think for a second, how can we make this a full outer shell? So based on the logic from the previous example, from the previous video of NaCl, when we transfer one electron to make full outer shell from both elements, well, in this one, you can use the same logic, but instead of transferring one electron, we transfer 2 electrons. So we have 1 electron transferred there and 1 electron transferred there. So our product will be Mg and O. And you can see here, Mg has lost the 2 electrons in its outer shell. Therefore, it's an Mg2 plus now, and O has gained 2 electrons from Mg. Therefore, it's O2 minus. And why do we have this 2 plus and 2 minus? Well, it's very simple. Electrons, they are negative, so they have a negative charge on them. So if you lose an electron, if you minus a minus, you will become a plus. So apparently here, magnesium lost 2 electrons, so it lost 2 minus. So minus minus 2 becomes plus 2. In other case, oxide, in this case, it gained 2 electrons, so it plus 2 minus. So after all, it's going to have a charge of 2 minus. So instead of transferring 1 electron like sodium chloride, it transferred 2 in this case. So based on the previous example, I would like you to try and work out the product if we are trying to bond calcium and sulfur together. So just pause the video right now and see if you can come up an answer. I'll be revealing the answer right now. So the way I'll do it is I will look at what group they are in, because in order to know how to obtain full outer shell, we have to know which group it is. So we have to know how many outer shell electrons there are. So we have calcium in group 2. So it means it has 2 electrons in its outer shell. So in order to become a full outer shell, it has to lose 2 electrons. And sulfur, on the other hand, is in group 6. And it lacks 2 electrons to become a full outer shell. So it needs to gain 2. So we have calcium Ca2 plus S2 minus equals Cas. And the reason why it's 2 plus, because calcium lost 2 electrons. And the reason why it's 2 minus for sulfur, because sulfur gained 2 electrons. Now we shall look up some really weird examples. So here we got MgCl2. And Mg again stands for the magnesium, and Cl, as most of you should know, stands for chlorine. So how are we going to bond these two together? So again, I've drew the valence electron diagram just for you to visualize easier the atom of magnesium and chlorine. So just pause the video right now. How are we supposed to obtain full outer shell with these two elements? You might have encountered several issues right here because magnesium clearly has two outer electrons. So it has to lose both electrons in order to have a full outer shell. So this one must go and this one must go too. Whereas chlorine, it needs to gain one electron to have a full outer shell. Well, this is weird because chlorine can only gain one, whereas magnesium has two. There's no way that magnesium could put two of its electrons on chlorine because that would make it 9 electrons in an outer shell, and that's not a full outer shell. So to solve this, we need two chlorines right here. So we got one electron transferred to this chlorine, whereas we have this electron, it has nowhere to go. Therefore, we need another chlorine. So we need two chlorines to support this electron to go there. So this bond actually involves two chloride ions and one Mg2 plus ions. So what we call this is a drop and swap method. So drop and swap method basically means if we have magnesium plus chlorine, we know magnesium is in group 2, so it has two outer electrons, therefore it makes sense for it to lose two electrons. Whereas chlorine is in group 7, so it makes sense for it to gain one electrons. But we all know a full outer shell can only take 8 electrons, so it's impossible for chlorine to have 9 electrons in its outer shell. So in this case, we have Mg2 plus as the charge because it lost 2 electrons, and Cl minus because it gained 1 electron. And we call this MgCl2. Reason why is because we took this 2 charge, we put it to chlorine, and we took this minus 1 charge and we took it to Mg. So basically we just swapped the numbers here. So that's why we call it drop and swap. We drop the charges and we switch them. So Mg, it got 1. And Cl, it got 2. So basically, the final formula will be MgCl2. You basically swap the charges. It's pretty simple. Now let's take a look at an extremely weird one. We have this Al2O3. So Al stands for aluminium. It's a very common metal in our daily life. Aluminium, and we have O. So O is just oxygen. From the previous example, you might know. So again, I've drew this electron diagram for you to visualize. So aluminium is in group 3, so it has 3 valence electrons, 3 outer electrons. And oxygen is in group 6, so it has 6 outer electrons. So again, I would like you to work out how can we fill the outer shell of these two elements. Work towards it slowly. We know that aluminium has 3 outer electrons, so it has to lose all 3 to be a full outer shell. Whereas oxygen, it has 2 empty electron slots, so it has to gain 2 electrons to be full outer shell. Right, so let's start to transfer the electrons. So let's transfer this one to here, that makes sense. And let's transfer that one to there, that makes sense. Now this oxygen is full outer shelled, so this one is happy now, it has a full outer shell. Well, we got a problem here, we still got 1 electron left for aluminium. Aluminium is not happy because it still has 1 electron left. So what does that mean? Based on the previous example's logic, we need to include another oxygen. So this electron can go there. Well, we got another problem, this oxygen is not happy again because it needs 1 more. So where do we get that 1 extra electron from? Then we need another aluminium. We need another aluminium to transfer its electron to here. So this oxygen is happy, while this aluminium is not again. So we need another oxygen right here. So this electron can transfer there, and whereas the bottom electron can transfer there. So now just double check. Every atom right now has a full outer shell. This one got 2, it has a full outer shell. This one got 2, it has a full outer shell. And this one got 2, it has a full outer shell. This one lost 3, so it has a full outer shell. And this one lost 3 too, so it also has a full outer shell. So electron transfer is done. So as we can see, that method is still pretty time consuming because you have to draw out all those electrons, you have to draw out all these arrows, and you have to try to fit the outer shells. So we can just quickly work out how it's going to look like when it's bonded using the drop and swap method. So The same process we can work out in just 30 seconds using the drop and swap method. So again, we have aluminium plus oxygen. So we know aluminium is in group 3, so it has to lose 3 electrons to be a full outer shell. Oxygen is in group 6 on the other hand, so it has to gain 2. Well, again, we know aluminium lose 3, so it must be a 3 plus charge because it's losing 3 electrons. And oxygen, on the other hand, gained 2 electrons, so it must be 2 minus. So in this case, we can just drop the charges and switch them. So you see the 3 in aluminium goes to the oxygen, and the 2 on the oxygen goes to the aluminium. So it makes sense, and the equation is balanced. We have 2 aluminium right here, 2 aluminium right here, and we have 3 oxygen right here. So the final product is aluminium oxide. So next time, if you see some really weird charges, you don't have to be scared. Just drop the charges and switch them. All you have to do, we got this 3 plus to the oxygen and the 2 minus to the aluminium. So in order to summarize, I made up some rules. So the rules are here. Group number determines how many electrons an atom gain or lose when ionically bonded. So that makes sense. If we're in group 1, we lose 1 electron. We're in group 2, we lose 2. Group 3, we lose 3. On the other hand, group 7, we gain 1. Group 6, we gain 2. Group 5, we gain 3. And the reason why there's no group 4 is because group 4 rarely ionically bond. So we don't need to talk about group 4 now. Well, there's one question. Why does group 7 must gain 1? Can it not lose 7 electrons? Well, it can, but it's very energy inefficient. When we talk about chemistry, it's all about energy. We are trying to produce something with the lowest possible energy. So if we are to lose all 7 electrons for group 7 instead of gaining 1, that's going to cost us a lot of energy. So another rule is amount of electron lost or gained determines charges. That makes sense. If we lose 1 electron, we get plus 1 charge. If we gain 1 electron, we get minus 1 charge. And final one, use drop and swap method to ensure the charges balance out. Because after all, an ionically bonded molecule, it has no charges at all. So the charges should eventually balance out. If we were to look at the previous example of Al2O3, we see that 2 times 3 plus is 6 plus. So aluminium has a 6 plus charge, and 2 minus times 3 is a 6 minus. So 6 plus 6 minus, we have 0. So the overall charge is actually 0. That's the end of this video, and I hope you now understand ionic bonds in a more detailed way. So make sure you like this video and you subscribe to my channel and share it to all your friends who hate science. And next episode we will be talking about covalent bonding, which is a different type of bonding but involving gas. Thank you very much. See you next time.